All right, in section 11.3, we're going to really understand how urine is formed. The nephrons are absolutely brilliant. Remember in the last section, we talked about the idea that kidneys are made up of over 1 million nephrons, and that a portion of these nephrons are up here in the medulla, the very outside, up in the cortex, the very outside of the kidney, and then the medulla is down here. So there's a couple of things that we need to understand that are really incredible. One is this medulla is very, very salty. And I want you to remember this idea that things move from high concentration to low concentration. They're also really impacted by pressure. So we're going to have 3 key parts to urine formation. The first one is glomerular filtration. We're going to deliver blood right here into the glomerulus, and it's at a very, very high pressure. And this pressure is going to force almost everything possible out of the bloodstream and into the nephron. In fact, too much is going to leave the bloodstream, so we need to pick some of it back up again. So the next piece of this will be reabsorbing a lot of that filtrate that we just formed. So for example, up in here, this tubular reabsorption, we're going to start absorbing nutrients, we're going to start absorbing water, we'll absorb salt. And then as it starts to be, it's really reduced in volume by this point, we've got a little bit more left to do, and that will be this tubular secretion of some molecules that we couldn't get across the glomerulus up here. We'll use some ATP and some pumps to be able to secrete that out. And then we'll head down through the collecting duct, which can be very affected by hormones, and this is where we'll be able to start maintaining our salt and water balance based on hormones that are present. So let's take this apart. The very first place that we need to start is to look at glomerular filtration. So remember 3 parts: the filtration, tubular reabsorption, and tubular secretion. So let's start with glomerular filtration. This is that knot of capillaries that's delivering blood directly into the glomerulus. Anything that's small enough to cross across that barrier will. You can see the blood's delivering it to this very thin layer of cells, and we're moving a tremendous amount of fluid into the nephron up in here. Water and small molecules move into that capsule. Water, nitrogenous wastes, nutrients, and salts are all going to be moved into the nephron. Some things like blood cells and platelets and really large plasma proteins, some molecules like antibiotics are just too big to cross that barrier, and we'll deal with those later. But initially, we've got a really large quantity of filtrate that's produced. So now we're going to move to the reabsorption portion. Many molecules have moved into the nephron that we still want to keep in the body. So remember, we're cleaning the blood. So we're going to move a lot out, and then we're going to reabsorb the things that we want to keep. So most of the water is reabsorbed, some of the nutrients, and even some of the salt is going to be reabsorbed here. Some of the things that we don't reabsorb is a little bit of the water. Most of that nitrogenous waste that came from breaking down protein, we're not going to pick back up. And some excess salt, all will be eliminated out of the body in urine. The last stage of this is tubular secretion. Remember, we had some things like drugs, a few hydrogen ions, even some creatine that's just too big to cross across the glomerulus. We have to physically secrete using ATP, and that'll happen at the end of the nephron in that distal convoluted tubule. So let's look at this a little more closely. Initially, we make a tremendous amount of filtrate. Anything small enough to cross the barrier moves into the nephron. Then, as it's moving through this proximal convoluted tubule, we're going to start picking up some water, a little bit more of solutes. We can even secrete a little bit more into the proximal convoluted tubule here. As it descends through the loop of Henle, this medulla in here of the kidney is very, very salty. And so what happens is water moves from an area of high concentration to low concentration, and so this salt salty environment will pick up even more water as it descends. So remember, the volume of our filtrate's going down because we're continuing to pull things back out of the nephron and putting it back into the bloodstream in the body. When it reaches this point of the loop of Henle, it is no longer permeable to water, but pumps start moving salt back out of this filtrate as well. So we move salt out here. It's part of how we keep it salty in this environment down here in the medulla. It's also how we keep some salt in our body. As it enters the distal convoluted tubule, we'll continue picking up a little bit of water and a little bit of salt, but we're also going to use ATP right up in here, and we will pump anything that was too large to be filtered over here, we will pump into the nephron. All of the materials that are in this nephron at this point, unless they are reabsorbed, now have a collecting duct that with direct access to the nephron and then the bladder. So anything here is going to be urine that will be eliminated from the body. And then the next section, we'll talk about how we maintain homeostasis.